Okay, so I've had some questions about DNA replication and the lagging and leading strand. So I'm just going to do a demonstration here to try and explain what I'm really talking about. So in this case, the zipper is going to represent our parent strand of DNA, or the original strand of DNA. Now, originally it would be all like twisted, and then guy rays would come along and untwist it so that it is in the straight line that we see now. Then the next thing that would happen is that we would have helicase coming along, and helicase would be slowly unzipping the two different sides or the two different strands of this DNA molecule. So helicase would be working in this direction, slowly unzipping this DNA molecule, which just means breaking apart the hydrogen bonds that hold the two sides together. And then this area right here would be the replication fork, where it goes from being split into two strands into still in one strand. And in this case, the zipper itself would be our helicase molecule that is slowly unzipping this. Now remember, our parent strands are anti-parallel, which means one strand runs from 5' to the 3' direction, and then the other strand would be running 3' to 5', because our strands are always anti-parallel. Sorry, this is like blowing out a little bit. Okay, so that's our 5' end. So what's going to happen is the next enzyme that's going to come along is our primase. And what primase is going to do is it's going to put a little RNA primer on the 3' end of the parent strand. So now this primer is kind of making up the 5' end of the new strand that's about to be built. That allows for DNA polymerase 3 to come in and start building the new strand, which I'm going to show in green here. The new strand can only be built in the 5' to 3' direction, which is in the opposite direction of what the parent strand is in. So because this is the 3' end of the parent strand, it is the 5' end of the new strand, which means we can go from that 5' end towards the 3' end. So DNA polymerase 3 would be building this new DNA molecule right here from the 5' towards the 3', which is where the replication fork is. Okay, and this would be attaching as we go. Okay, so this would be the leading strand because it can be built in one continuous chunk towards the replication fork. Now what happens on the lagging strand, which is the one down here in this case, is our primase is going to come in, and again the primase has to come in on the 3' end of the parent strand, which is not this end. So that would be down here is where the little RNA primer would get put on the parent strand. And then our DNA polymerase could build from what is the 5' end of the new strand down towards what is going to be the 3' end of the new strand. So that's all fairly straightforward, but what happens then is helicase is going to keep unzipping this further and moving the replication fork further down. And so with our leading strand, that means it just continues to build towards that replication fork, because the replication fork is moving in the 5' to 3' direction for that strand. However, with our lagging strand, we now need another RNA primer to be put in. And then the DNA polymerase 3 that just built this section here. I don't know why I can't get this to white balance. Give me 1 second here. Okay, it's a little bit better. The DNA polymerase 3 that was just right here and built this strand is now going to backtrack, attach onto this new primer here, and build in this direction again until it gets to the previous primer. Okay. These two little chunks here, this one and this one, become the two Okazaki fragments. And a ligase would have to come in and attach them together where that primer is right now. And then the helicase would come in and unzip this even further. The leading strand would just continue building in the 5' to 3' direction. Again, remember, for the parent strand on this side, this would be the 5' end. But for the new strand that's being built, on the top, this is the 3' end that it's building towards. On the bottom, this is the 5' end. Okay, and that is why this new strand that keeps getting built has to be built in chunks. As more of the parent strand is opened up, again, that top strand just keeps getting built in one long strand. This bottom one is going to need another chunk, so we have another primer that gets put in. And then the DNA polymerase 3 that just built this chunk can backtrack to the newly opened part of the parent strand and build back in the 3' direction again to make another Okazaki fragment. I hope that kind of explains it. If not, let me know if you still have questions.